vocabulary that you should be comfortable with. Equations with radicals that have variables in their radicands are called radical equations. Okay, a radicand is that's your symbol. This is called a radicand. Okay, simple enough, right? What is a radical equation? Use radicands. Solving radical equations. So when we're solving radical equations, we are first going to isolate the term involving the radical on one side of the equation. And then we're going to square both sides to eliminate the radical. And we're going to use a plus or minus symbol when necessary. Then we're going to solve the resulting equation. Okay. Then we're going to check each solution in the original equation. Okay. That's the key thing is we're going to check each solution in the original equation. There's always a possibility that the solution is extraneous, which means it works in the modified equation, but it doesn't work in the original. And if it doesn't work in the original, then we'll come down to our real solution versus an extraneous solution. So here we go. We have example 1. What is the solution of 2 square root of x plus 9 equals 21? So these are our steps that we're going to follow. We're going to get the radical by itself on one side of the equation. So in order to do that, what is the first thing I need to do in order to get the radical by itself? Remember, we have to do our PEMDAS backwards. So we're SADMET. There we go. So we're going to have to subtract 9. And now I'm left with 2 square root of x equals 11. Okay. We need to make sure that the coefficient, the number in front of the radical, is 1. So what do I need to do to do that? Divide by 2. And now we're left with the square root of 11, not 11, square root of x equals 11 divided by 2. Then what is our third step we need to do? So we're going to square each side. So we square this side, we square this side. And when we square a fraction, that means you're squaring the numerator and the denominator. So we end up with x equals guys, I did some bad math. I was like, that is not 11. That's 12. Oh my goodness, wake up. And y'all just let me keep going. I was like, what? I didn't go right. So we end up with 6 squared, which equals 36. So the answer that we get is x equals 36. We're going to check ourselves to make sure that we did it correctly. So we're going to substitute it back into the original. So we have 2 square root of 36 plus 9 equals 21. True or false? So we end up with 2 square root of 36 is 6 plus 9 equals 21. That gives us 15 plus 9. That gives us 12. I am horrible right now. No, you simplify first. 12 divided by 2, and then you square it. Equals 21. And is this a true statement? Yes. So we know that the solution is 36. All right. So these are considered our easier type problems. So what I would like for you to do, you're going to do these 4 problems. So give you about 4 minutes to do these 4 problems. Before I let you go, we're going to set them up together. So if you notice here on the first 2, they tell us what our y is. So we know that y equals 30. So we have 30 equals 6 square root of x plus 1. Here it tells us that y equals 5. So we have 5 equals 10 square root of x minus 4. So go ahead, we're gonna pause and I'm gonna let you go. All right, so let's check and see how we did. So these are the solutions you should have ended up with. Okay, so number 1, we have x equals 24. And to check yourself, so these problems you shouldn't get wrong because you can always check yourself. So 30 equals the square root of 6 times 24 plus 1. That gives me 30 equals 6 times the square root of 25. So 30 equals 6 times 5. Is that a true statement? Why, yes, it is. Okay, here we have 4 1/4 or 17/4, however you choose to write it. We're going to plug that in. So we have 5 equals 10 times the square root of 4 and a 4 minus 4. That leaves us with 5 equals 10 square root of 1/4, which equals a half. So we have 5 equals 10 times 1/2, and that is a true statement, so it checks out. Here we have 25, so you should have got x equals 25, so checking it, you have the square root of 25 plus 6. That's 5 plus 6, and that equals 11. Check. Last, checking again, you have the square root of 36 minus 2 equals 4. That gives you 6 minus 2 equals 4. Is that a true statement? Check. Okay. So again, you can always verify before you proceed. Okay. Equations containing radicals can be solved by isolating the radical on one side of the equation and then raising both sides to the same power. That would undo the radical. So this does not just work with square roots and squares. It also has the same rules that we would follow for cubes and cube roots and fourth roots. Does that make sense? So you would do the same thing that we just did with the squares and the square roots with the other radicals. Cool? But we are focused on squares still. So the problems may get a little lengthier. And so as they do, then you just follow the steps. For some reason, my numbering disappeared, and I don't know why. If yours is still there, great, but my numbering disappeared. So just know that we're following 1, 2, 3, 4, 5. So here, if I need to solve for x, the first thing I'm going to do is add 2 to both sides, right? So I add 2 to both sides. And I'm left with 2 square root of 2x plus 2 equals 12. Then I divide both sides by 2. And I'm left with the square root of 2x plus 2 equals 6. Now I'm going to square both sides. And I'm left with 2x plus 2 equals 36. And now, is this not just back to being a pre-algebra problem? A 2-step pre-algebra problem, right? I'm going to subtract 2 and then divide by 2. So I subtract 2 and then divide by 2. And I'm left with x equals 17. Yes. That's why I re-put the equation at the top of the box. You see it? All right. So again, we get x equals 17. I'm like, I don't know if I did that right. Well, what should I do? Plug it into the original equation. So 2 square root of 2 times 17 plus 2 minus 2. And I want to know, does it equal 10? So we have 2 square root of 34 plus 2 minus 2. And we're going to follow PEMDAS, so we're getting everything underneath the square root, because that counts as our exponents. That gives me 2 square root of 36 minus 2. And that gives me 2 times 10. I can't even talk. 2 times 6. My brain is going ahead of itself. 2 times 6 minus 2. And does that equal 10? Why, yes, it does. Okay, so just because the problem gets lengthier, does the process change? No, you just have a little more steps. Okay, so notice it was just a couple more steps, but still fairly simple, correct? We're just still using inverse operations, not adding on any new tricks to the trade, just still inverse operation. So I'm going to give you 5 minutes to quickly do these, and or less, seeing how you go. But here are your practice ones. All right, let's see how we did. So if you look up here, these are the solutions you should have gotten. And you can go through and do your quick check. So on the first one, if I plug this into the original, square root of 169, does it equal 13? Yep. On the second one, if I plug 8 into the original, so I have 3 square root of 2 times 8, gives me 3 square root of 16, gives me 3 times 4. Does that equal 12? Yes. On the third one, I'm going to plug into the original. 3 times 7 plus 4 minus 1. That gives me the square root of 21 plus 4 is 25 minus 1. That gives me, where we're at, 5 minus 1. Does that equal 4? Yes, it does. And then the last one, we got negative 3. So I'm going to plug it into the square root. 6 minus negative 3 plus 2. A negative times a negative is a positive. So I get the square root of 9 plus 2. Square root of 9 is 3. Does 3 plus 2 equal 5? Yes. Okay. All right. So now we're going to go into a different type of problem where we're going to have what's called an extraneous solution. Okay. An extraneous solution may satisfy equations in your work, but it does not make the original equation true. Okay. So we always check possible solutions in the original equation. An extraneous solution is going to happen when you have a variable outside of the radical. Okay. So if I have a variable outside of a radical, meaning if I have x equals the square root of x plus 1, there's going to be a potential for an extraneous solution. Okay. So here we go. With extraneous solution problems, we're going to have to remember some of our factoring skills potentially, how to FOIL, and things like that. Again, please excuse my weird numbering when I put into PowerPoint. Don't know how or why that did that, but please excuse it. So here we have the square root of 17 minus x minus 3 equals x. So the first thing you want to do is isolate the radical. In order to isolate the radical, what do I need to do? I want to get the radical by itself. So who needs to go away? The 3, right? So I'm going to add 3 to both sides. So I end up with the square root of 17 minus x equals x plus 3. I'm going to square both sides. Now notice, because this is x plus 3, when I square both sides, it turns it into a binomial square. Okay? I'm going to rewrite this in standard form. And rewriting it in standard form means that I'm going to FOIL. So I'm going to have to apply FOIL here. Okay? When I have something squared, what's happening is I'm squaring the first, doubling to get the middle, squaring to get my third. So x squared is x squared. What's 3 doubled? 6. What is 3 squared? 9. So after all FOIL is said and done, I'm going to end up with x squared plus 6x plus 9. Okay? When you're writing in standard form, that means that all variables and numbers are on one side and it's equal to 0. So in order for that to happen, I'm going to have to subtract 17 and add x. So now I have 0 equals x squared plus 7x minus 8. And now I'm just going to do some good old-fashioned factoring. What multiplies to give me -8, but adds to give me 7? What are my magic numbers? What kind of 1 and 8? What kind of 1 and 8? A -1 and a +8. And because of that, x has to equal 1 and x has to equal -8. So these are my two possible solutions. You have to check both because one could be what's called your extraneous solution and one is your real solution. So I'm going to check x equals 1. I'm going to plug it into the original. So in the original, I have 17 minus 1 minus 3 equals 1. 17 minus 1 is 16. Square root of 16 is 4. 4 minus 3 equals 1. Is that a true statement? Yes, it is. So this checks out as a real solution. I'm going to do the same thing with the -8. So I'm going to test x equals -8. I'm going to plug it in. So we have the square root of 17 minus -8 minus 3 equals -8. A negative times a negative is a positive. And that gives me the square root of 25 minus 3 equals -8. What is the square root of 25? 5. Does 5 minus 3 equal -8? No, this is false, not true. So this is our extraneous. So this is my real solution. This is my extraneous solution. So this is what we've been building our skills up to. What are your questions, comments, or concerns? Awesome. Okay, so I would like for you to try these two types of equations. So if you look on number 1, we have a radical on both sides. So I put a little hint there for you. And then if you look at number 2, we have a variable outside of the radical. All right, so on here, your hint was you had to square both sides. And you're able to do that because are there any values outside of the radicals? No. So we're going to square both sides. And that sets both sides free. And when you do that, didn't it become a fairly easy problem? Yeah. So you're going to combine like terms. Cancels, cancels. And I'm left with x equals 2. Okay. And I'm going to check that it works. So I'm going to plug it back into the original. And I have 5 times 2 plus 1 equals 4 times 2 plus 3. That gives me 10 plus 1 is 11. 8 plus 3 is 11. Oh my gosh, you checked out. It works perfect. How do we feel? All right, on number 2, I have an x outside of the radical. So I need to get the radical by itself. So I'm going to subtract 5. And that leaves me with x minus 5 equals the square root of x plus 7. I'm going to square both sides. And because there's already terms here, it turns it into a binomial squared. And again, the shortcut to FOIL here is you square, you double, then you square. So x squared is x squared. -5 doubled is -10x. Negative 5 squared is positive 25. And that leaves me with x plus 7. I'm going to combine like terms. And we have x squared minus 11x plus 18 equals 0. So it multiplies to give me 18, but adds to give me negative 11. You should have gotten x minus 9, x minus 2. And so x has to equal 9 or x has to equal 2. So these are my two that I'm going to check to see if they are extraneous. So when I plug 2 in, I have 2 plus 7 is 9. Square root of 9 is 3. 3 plus 5 is 8. And I need to equal x. That doesn't work out. So that makes this my extraneous. If I plug 9 in, the square root of 9 plus 7 is 16. That we're still being surprised at the end of the year. But yes, you use inverse operations. So what's the opposite of adding? Subtracting. What's the opposite of multiplying? Dividing. Okay. You want to check your work at the end if you don't feel confident by plugging back in for x. Bam. Big surprise. Here we go. So we're going to do the first example together. Then I'm going to have you do the second example with your group. Cool. All right. So we have the cube root of 5x minus 1 equals 4. And it wants us to solve this. So what's the opposite of cube root? To cube in. So in order to cancel out the cube root, what do I need to do? Cube. And what I do to one side, I have to do to the other. So this cancels out my radical, and I'm left with 5x minus 1 equals 4 to the third. 4 to the third means that I have 4 times 4 times 4, which equals 64. So we have, is it okay if I just write 64 right here? All right, now we need to get x by itself. So what do we need to do? What's the first thing we need to do to get x by itself? Add the 1, because you can't just go straight to the x. You got to work your way there. So we have 5x equals what's 64 plus 1? 65. What's the last thing we need to do to get x by itself? Divide by 5. Oh my gosh. And what's 65 divided by 5? It is 13. Yay. We did it.
Boom.
How do we feel?
You know, I feel good. I feel good.
Feel good? Totally doable, right? All right, here we go. Here is yours. Go for it. All right, let's see how we did. All right, so just because the 5 is here, if it bothered you, all you have to do is move it to the other side, right?
Yep. No.
And then the process begins the same. What did you do?
Wait, I didn't.
You didn't have to. You
Okay.
cube both sides, and we're left with 7x plus 6 equals, what's 5 times 5 times 5?
125.
125. And then you should have subtracted your 6,
119.
and you get 7x equals 119. Then you divide it by 7.
And it's 17.
7 goes into 11 one time with the remainder of 4. 7 goes into 49 7 times. And your answer is 17. How do we feel? Doable?
Amazing.
All right, we got to do our traditional real world example. Here we go. Earth science. Okay, for meteor crater in Arizona, the formula D equals 2 cube root of V divided by 3/10 relates the diameter D of the rim in meters to the volume V in cubic meters. What is the volume of the meteor crater? All values are approximate. Okay, well, notice here how our diameter right here that's given to us, it's in kilometers. But what are the values in the formula? Meters, right? The values in the formula are in meters. So before we can do anything, what will we need to do? Convert, right? All right, so I don't know what your teachers did, but my 5th grade science teacher, this is how I was taught to convert with customaries. And it's kangaroos hop down mountains drinking chocolate milk. Okay, that's how I learned it. So this is your kilo, your hecto, your deca, your meters, your deci, your centi, and your milli. Okay, so this is your customary units, right? So your teachers, I don't know what y'all learned or how y'all learn how to convert between customary units, but I learned it as kangaroos hop down mountains drinking chocolate milk. Okay. When you hop down, you multiply. When you hop up, you divide. That's literally how I learned it. And that's because our customary units is based off of powers of 10, right? 10 to the first, 10 to the third. I don't know. Yes. Oh, what are you learning in science?
I didn't learn anything in
Physics.
science.
So if I have 1.2 kilometers and I need to get to meters, I'm going to hop down 1, 2, 3. I hop down 3, which means that I'm going to multiply. Down is multiply, up is divide.
Yeah.
I went down, so I'm going to multiply, which just means that I'm moving my decimal place to the right. So down is multiplying, up is dividing. So I'm just moving my decimal places. How many places to the right? 3, because it's 10 to the third, which is 1,000. So you're doing 1.2 times 1,000, which just means I'm going 1, 2, 3, which makes this 1,200 meters. So that's converting in customary units. All right. So now that I have what D is in customary, so I know that this is 1,200 meters. Now can I plug it in and solve the equation? Yes. So we have 1,200 equals 2 to the cube root of V divided by 3/10. And now I just got to get V by itself. Okay, so on the outside, I have 2 being multiplied. The opposite of 2 being multiplied is for 2 to be divided. What is 1,200 divided by 2? 600. So we have 600 equals the cube root of V divided by 3/10. What's the opposite of cube root? Cube. Now I'm going to keep it as this until the very end. So we have 600 cubed equals V divided by 0.3. And then what's left for me to do? Times 0.3, multiply. And what I do to one side, I do to the other. So in the calculator, I'm putting in 600 to the third times 3/10. And that's going to give me my volume. So let me pull up my handy dandy calculator. So I'm doing 600 to the third, and I get 216 million times 3/10, and I get 64,800,000. So that's the 64,800,000 cubic meters is the volume. So I'm gonna write 64,800,000 cubic meters.
Hey. That was like a little Dwayne Wade or Ron James moment.
Okay,
Little alley-oop.
You can
Line
move
up.
All right.
to your room. I will help you move.
thanks.
Sam.
All right, question next. So we're gonna be here solving equations with rational exponents, okay? So it's gonna get a little different here, and there's a couple ways of solving this. But the main thing you want to remember that a rational exponent means that you have an exponent that is a fraction, okay? That's what a rational exponent means, okay? Second, you want to isolate the term or factor with the rational exponent using inverse operation. So you want to get it by itself, okay? And then you want to raise the side of the equation to the reciprocal of the exponent. And what does reciprocal mean? Anyone, what does it mean to, what's the reciprocal of a number? You flip it. It's when you flip it. So if I have 2/3, its reciprocal is 3/2, right? 2/3 reciprocal is 3/2, okay? Then you're gonna raise the side of the equation to the reciprocal exponent, and you simplify both sides. Now, one thing we gotta remember is that when you have an exponent, so if I have x to the 2/3, what this means is that you are taking the cube root of x and squaring it. Does that make sense? Do you remember that? You're taking the cube root and squaring it. There's two parts. So if there's a fractional exponent, that means there's two things that's taking place, okay? I have a power and I have a root, okay? Do you remember that? Yes, ringing a little bit of bells, for exponents, okay? All right, let's dive in. So here we have 3 times x plus 1 to the 2/3 equals 12. So step one is you want to get your factor that has the exponent by itself. So what needs to move so that x plus 1 to the 2/3 is by itself? 3. How do I move the 3? Divide it. Perfect. So I divide both sides by 3, and I'm left with x plus 1 to the 2/3 equals 4. Okay. The next thing it said first to do is to find the reciprocal of the exponent. So the reciprocal of 2/3 is 3/2. I see where he was going. Okay. 3/2. And what I do to one side, I do to the other. This is going to cancel this side out. And I'm left with x plus 1 equals 4 to the 3/2. So what this is telling me is that I am taking the square root of 4 and I am cubing it. Does that make sense? So we're taking the square root of 4 and we're cubing it. Or we're cubing 4 and taking the square root. Does it matter which way you go? No, it does not. So which way do we want to go? We want to square root, then cube it. All right.
No, that's cube and the square root.
Either way. So we'll do both just for fancies. Here's our last notes, you know. Let's go out with a bang.
Who made the math right? You know what I'm saying?
Somebody.
Like who made math like?
All right. So if we did it where we did 4 cubed and then took the square root, what is 4 cubed? What's 4 times 4 times 4? 64. And then the square root of 64 is positive and negative 8, right? So you could have done it this way or the other way. So the other way is you're going to square root 4 and then cube it. What is the square root of 4? Positive negative 2, right? And then when you cube positive or negative 2, what does it become? Positive negative 8. Does it matter which way you do it? No, the end results are the same. Okay, so we have x plus 1 equals plus or minus 8. What does the plus or minus mean? It's either going to be a positive or a negative. We have that both happening, right? Because we took an even root. All right, what's the last thing I need to do? Subtract the 1, right?
Yes.
So we have x equals -1 plus or minus 8. And we talked about this during our square root unit. That means you have two answers, right? One when you add 8 and one when you subtract 8. What's -1 plus 8? 7. What's -1 minus 8? -9. So our two answers are
7 and -9.
7 and -9.
What number two times?
No, I think I do question. No.
Okay, now why do we have two answers? The reason why we have two answers again is remember that we had an even root. Okay, that's the only reason why, is because we had an even root. If we had an odd root, will we have two answers? No. Okay. All right, we're gonna look at odd roots. Ready? So example 5. Yes. So example 5 is already written as a radical. Example 5 can also be written as 3 parentheses x plus 1 to the 5/3. So it could have been left as a rational exponent, but we went ahead and wrote it as a radical and an exponent instead of keeping it as a rational exponent. Okay, these are equal problems. Does that make sense? They are the same problem. I forgot the plus 1. Just written in a different form. Okay, so your other option is to go ahead and in the beginning, take your rational exponent and write it as a radical and exponent separate, and then go from there. Okay. All right, here we go. So the job is to get this by itself. So what needs to move first? The 1. So we have to subtract 1 from both sides. So we're left with 3 cube root of x plus 1 to the 5th equals 96. Now what needs to go? The 3. So I'm going to divide both sides by 3. And we're left with the cube root of x plus 1 to the 5th equals 32. Now what do I need to get rid of? The 3, the root. How do I get rid of that? No, you put a power to it. So it's 3 to the power, to the 3rd power. So it's gonna, now we're left with x plus 1 to the 5th power equals 32 to the 3rd power. How do I get rid of an exponent?
This, the thingy, what's it called?
The root.
Yeah.
Finding the root of it, right? So the opposite of to the 5th power is to find the 5th root. Okay. Instead of me having to write it as a 5th root, it's okay if I just write it as 3/5. I can, because the denominator of the exponent is my root. The denominator of my exponent is the root. All right, so what number times itself 5 times makes 32? What number times itself 5 times makes 32?
4, 6, 5, not 5.
2 times 2. 2 times 2, 4. 4 times 2, 8. 8 times 2, 16 times 2, 32. So the 5th root of 32 is 2. What number times itself 5 times makes, all right. All right, what's left to get x by itself? -1. All right. So what does x equal? What's 2 to the third minus 1?
X equals 1/3. What's the third time?
What's 2 to the third?
What? Oh,
2 to the third means 2 times 2 times 2. What is that? 8. What's 8 minus 1?
7.
So my answer is 7.
So this is our last example. Yeah, why don't you go to the bank with that?
So on this one, I'm going to show you, if you don't want to work it as a fraction, you can also write it as a root. So as a root, this would be 2, and your denominator is your radical. So it's 2 cube root of x plus 3 squared equals 8. Whichever way you feel comfortable solving it is up to you. Okay, they're both the same. It's going to end in the same.
You know the teacher from Charlie Brown?
Okay, so not right now. So first thing is to get our rational exponent factor by itself. But what do I need to do to get this by itself? Divide. So we're left with x plus 3 to the 2/3 equals 4. Okay, to get rid of the rational exponent, you multiply by its reciprocal. What is the reciprocal of 2/3? 3/2. So I multiply by 3/2. What I do to one side, I do to the other. Cancels it out. So we're left with x plus 3 equals the square root of 4 to the 3rd. Does that make sense? My denominator is my root. My numerator is my power. We see that? Okay, what is the square root? What is 4 to the 3rd? 64. What is the square root of 64? Plus or minus 8. Because when you take the square root of something, it produces a positive and a negative. What's the last thing I need to do to get x by itself? Subtract 3. So x equals -3 plus or minus 8. What does the plus or minus mean? You have to add and subtract. So what is -3 plus 8? 5. What is -3 minus 8? A -11. So your two answers are 5 and -11.
Oh my God.
Nope.
Oh.
All right. It's not in your notes, but just to go over with you, if all else fails and you have a graphing calculator, you can just purely use, especially when there's larger numbers, you can use your graphing calculator to solve. So if you remember these steps, they're right here. 1, you graph the left side of the equation. 2, you graph the right side of the equation. And then 3, you're looking for the what? The intersection. You're looking for the intersection of the two. Okay, the x coordinate is the solution. Sometimes you might have more than one intersection, so make sure you write them both down. All right, that is the last and final thing I have to tell you for algebra dose.
167. It's in order.
There you
So
go.
whenever you go in my notebook, it's just have to